Foreign experts suspect that there may be more than a quadrillion exoplanets in the Milky Way alone, with about 1/5 of them resembling Earth. Additionally, there are likely another quadrillion rocky moons with a structure similar to our own planet. This raises the question of the likelihood of us not being alone in the universe. Recently, researchers became intrigued when they spotted a planet in our closest cosmic neighborhood that bears a striking resemblance to Earth. The James Webb Telescope is the key to answering the questions that have intrigued researchers. We'll reveal the fascinating discovery made by the James Webb Telescope on Proxima B, an exoplanet. Exoplanets are planets located outside our solar system, whether they're in nearby star systems like Proxima Centauri or galaxies billions of light-years away. Detecting exoplanets is challenging because they are significantly smaller than the vastness of space and don't emit their own light. There are only two suitable methods for their detection. The first is the transit method, which involves observing the light spectrum of stars and noting periodic dimming caused by objects passing in front of the star, which could be exoplanets or other celestial phenomena. The second method involves measuring the gravitational field of the star itself. The slight changes in the star's position in space caused by the orbits of planets can be measured with precision. Direct discoveries of exoplanets are relatively rare. Overall, studying planets beyond our solar system remains a challenge. The new James Webb Space Telescope is expected to significantly ease the search for new celestial bodies in the cosmos. This highly advanced and costly telescope is equipped with precise measuring sensors that will allow for more detailed study of exoplanets than ever before. In 2016, the discovery of Proxima B marked a significant leap in planetary research. This period, when telescopes had limited planet detection capabilities, ushered in a new era in astronomy. However, the revelation of these planets brought forth numerous unanswered questions. What is the true nature of these planets? Do any of them bear similarities to Earth, and could some potentially support life? The James Webb Telescope, designed not only for distant planet analysis, but also for extensive exploration of our solar system's planets, is at the forefront of this new era. Situated deep in space, it boasts enhanced capabilities compared to its predecessors, including the ability to peer through cosmic dust clouds, expanding its range by millions of light-years beyond the Hubble Space Telescope. This achievement is made possible by its 16 massive honeycomb mirrors, coated in gold to capture delicate infrared rays, providing unparalleled insights into the cosmos. Spectrometers and color analysis filters are employed to study the light spectrum surrounding exoplanets, revealing crucial details like the presence of atmospheres on these distant worlds. By meticulously analyzing light wave properties, scientists can discern unique signatures of each exoplanet's interaction with its parent star's light. Webb's advanced technology can identify these distinctions across vast distances, producing spectrometer-based images of entire exoplanets. Valuable data such as planet density, mass, and even approximate size can be extracted from the patterns of light rays. In the quest for extraterrestrial life, biomarkers such as water and carbon compounds play a pivotal role, alongside the potential significance of oxygen. Yet the existence of life in the universe remains uncertain, as it is conceivable that alien life forms could have evolved under vastly different conditions. This includes the possibility of using different gases, surviving without light, or managing without extensive water resources. Despite significant progress, the exploration of exoworlds is still in its infancy. What information did James Webb uncover about Proxima B? Proxima B, one of Earth's closest exoplanets, is just 4.24 light-years away and orbits the star Proxima Centauri alongside Alpha Centauri A and B. Even older telescopes could determine its characteristics. Proxima B resides within its star's habitable zone, where it's close enough to receive sufficient heat for complex life to develop, while remaining distant enough to avoid excessive heat or radiation. Calculating the habitable zone in a star system is a challenge, varying based on the star's luminosity and size. The range where life can emerge differs significantly. Proxima B is only 7.4 million kilometers away from its star, whereas Earth is approximately 149.6 million kilometers from the Sun, making it just 5% of the distance. Nevertheless, scientists believe it's habitable due to Proxima Centauri's much lower brightness compared to our Sun. Besides the habitable zone, Earth-like qualities are crucial in the search for potentially habitable exoplanets. Proxima B is 1.27 times the size of Earth and is thought to have surface water and terrestrial features like mountains. However, there are notable differences, such as Proxima B's 11-day rotation cycle, with one side in perpetual light and the other in complete darkness, akin to the Earth's moon. Proxima B seemingly transmitted a direct signal to Earth, which was recorded by the SETI, Search for Extraterrestrial Intelligence, project in April and May of 2019. This signal was peculiar, operating at a frequency of 982 MHz, which is not typically associated with human-made satellites or spacecraft on Earth. The repetition frequencies and patterns of the signal were unlike anything previously encountered from space. Extensive research was conducted to determine its source, and some researchers eagerly suggested it could be a technological signature originating from Proxima B. However, further investigations ultimately revealed that the signal did not pass the scrutiny of other scientists. It was concluded that the signal likely resulted from terrestrial interference rather than being of extraterrestrial origin. Nevertheless, the signal remains unexplained to this day. It was heard only once for about 30 hours and never repeated, preventing further inquiry. The signal's uniqueness suggests it might have been a one-time cosmic event or a data recording anomaly. Had it been a technological signature from an alien civilization, it would likely have been detected more frequently. Nonetheless, researchers continue their efforts to closely examine Proxima B for potential signs of life. Researchers are exploring the use of artificial light as a potential indicator of extraterrestrial life. Avi Loeb, the leader of the study from Harvard University, believes that advanced civilizations would likely emit artificial light. Loeb and his team specialize in detecting such light around exoplanets. They initially considered configuring the James Webb Telescope to spot artificial light on both the illuminated and dark sides of Proxima B and other planets. However, their initial measurements were disappointing. The bright side of Proxima B was found to emit intense UV radiation and X-rays, but showed no signs of extraterrestrial light sources, making the existence of life less likely due to the high radiation levels. While the possibility of life on the planet's dark side cannot be ruled out, experts consider it unlikely. In a departure from traditional SETI, Search for Extraterrestrial Intelligence, listening efforts, a new project is set to launch with the aim of sending nanoprobes to our closest planetary neighbors for on-site exploration. Red dwarf stars, considered prime candidates for hosting life, will be the focus of this endeavor. The Breakthrough Starship program, funded by a billionaire, plans to deploy nanoprobes the size of matchboxes. These miniature spacecraft will utilize high-speed lasers to reach approximately 20% of the speed of light, covering distances that would take humans thousands of years to traverse in just about 200 years. Outfitted with miniature cameras, these nanoprobes will provide direct observations of their target planets. In a few hundred years, we may finally obtain conclusive evidence regarding the presence of life on Proxima B. The question remains: do you find this project exciting, or do you believe that we need to develop better technologies for making contact with potential extraterrestrial life forms in space? Share your insights and opinions. Don't forget to hit that subscribe button and ring the notification bell so you never miss out on our exciting updates about lunar discoveries and the future of space exploration. Remember, as we venture into the universe, the sky is not the limit. It's just the beginning. Keep looking up.